Okay, so this session now, it's being recorded. We're doing example 4, continuation of chapter 6. What is the sample size needed to estimate the population average to within $0.5 when the confidence level is 0.98% and the population variance is 25? Remember, he gave you population variance here. It's sigma squared. But if the population variance is 25, that means the standard deviation is the square root of 25, which is 5. I usually give you the standard deviation, but this question in particular, he put population variance. It's just good to know that if you know the population variance, you know the standard deviation because it is the square root of the population variance. This is the formula, guys, that you use when you do find the sample size when you're doing confidence interval for the mean. It's ZC sigma over E squared. This is we did in section 6.1. Now sigma is given to us, which is 5. E is given, which is 0.5, but you need to find ZC, which is the critical value. Okay, how do you find the ZC? I'm gonna repeat this. It's inverse norm. You take 98% and subtract it from 100%. And then divide the answer by 2. So 100% minus 98% is 2%. Divided by 2 will be 1%. How do you write 1% as a decimal? 0.01. And then 0, and then 1. And I think I remember the answer. Probably it's 2.33. There you go. Second, distribute. Inverse norm 0.01, comma 0, comma 1. Yes, if you round to 2 decimal places, it will be negative 2.33, but you always use the positive part, so it's 2.33. It doesn't matter. Even if you use negative, you're gonna square them, guys. So look what I did here. 2.33 times 5 squared divided by 0.5 squared. You will get 542.89 as an answer. But remember, guys, for sample size, you have to round up always. So it will be 543. Now, another example on the sample size, but when you do confidence interval for the proportion. That was the last thing I did yesterday with you guys. We did a formula for the sample size to estimate the population proportion. So you have 2 formulas, guys. You use this formula when he gives you talk about confidence interval for the mean. You use the other formula when he talks about confidence interval for the proportion. And look, it's clear. It says population proportion here. Within 3%, so E is 3%. When the confidence interval is 95%, no prior information on the sample proportion is available. So this is the formula. Let me write it down again. P hat times Q hat times ZC squared divided by E squared equals. The confidence level is 95%. You should know now, guys, what is the critical value at 95%. They're at the bottom of table 4. For 95%, it's 1.96. You could memorize this. I think it will be useful even if you memorize it or have the table handy. So it's 1.96. I mean, you could do it just like I did here. Take 100%, subtract 95%. You get 5%. Divided by 2, you get 2.5%, which is 0.025. And you run inverse norm at 0.025, comma 0, comma 1. That will give you 1.96 square. Margin of error, 0.03 square. Now, he didn't give me prior information about the P hat and Q hat. And remember yesterday, we decided to use 0.5 and 0.5 if no prior information are given. So, and if you do the math, guys, I did it right here. 0.5 times 0.5 times 1.96 squared divided by 0.03 squared, it will give you 1,067 point something. So we rounded up. Let me see. What was the answer? 0.5 times 0.5 times 1.96 squared divide by 0.03 squared. So let me see what the answer is. Oh, 1067.11. You have to round it up. It would be 1068. So I missed the one here. And this is 0.5. So rounds up to 1068. That concludes the chapter. What I'm going to do now, I'm going to do a review for the 3 sections with you guys. And then I have another review sheet ready for you. But then at the same time, I will demonstrate how you could do those problems using StatCrunch as well. A lab tested 12 chicken eggs. So N is 12. And found that the mean amount of cholesterol was 246. So X bar milligrams. With S equals, he gives you S, guys, 11.7 milligrams. Construct a 95% confidence interval. My question to you guys, is it a Z interval or a T interval? Can you guys tell me? It should be easy. This is where you guys, either you get the problem right or wrong when you use technology. It is T, and you guys, you know why it is T? Because he gives you S. Once he gives you S, that's it. It's a T interval. So now we know what to do on the calculator. It's T interval. And let's do it. Done. You go to stat, tests. It's number 8, guys. Should know that. I don't have data, so I go to summary. X bar is 246. S is 11.7. N is 12. Usually when it is a small sample size, guys, it's a T interval. And confidence level is 95. I already have this. And here you go. Let me write it down. 238.57, 253.43. So you write like this. 238.57 and 253.43. Now, if you're doing your homework, it might ask you to select a statement conclusion at the end. So you select with 95% confidence. You can say that the true means population, mean amount of cholesterol in an egg is between 238.57 milligrams and 253.43 milligrams. Any questions, guys? That is how you do it. So the key, guys, is to know, do I use a Z interval or a T interval? And that's an indicator right here. S means T. If this was a sigma, then it would have been Z interval. Okay, what I'm going to do now, guys, I'm going to switch screens and show you how you could have done this problem using StatCrunch. So pay attention for this. So I'm going to stop sharing here, and I'm going to take it to StatCrunch. I see. Just to find the StatCrunch. One second. Okay, look how you can use StatCrunch. You click on Stat. Okay. Now you should tell me, guys. We decided it's a T. So which one do you think I should use? It's somewhere in here.
T-stats?
T-stats, yes. And how many samples do I have here? I have only one sample, right? And what do I have, a summary or a data?
Summary.
Summary. You guys, you can see those pop-up screens, correct? All right. Okay. Okay, good, good. I just have to make sure I'm not the only one who's seeing the stuff. So sample mean. The sample mean is 246. I'm going to do the same exercise. The sample standard deviation is 11.7. The sample size is 12. This is for chapter 7, hypothesis testing. We're not doing that. We're going to go to confidence interval. And the level is 0.95. I'll keep it because that's what I want. And compute. Here you go, guys. This is the lower limit. You see the confidence interval is the lower limit and the upper limit. 238.566, 253.43, and that's the confidence interval. This is the degrees of freedom, which is 11, 12 minus 1. All right, so that's how you do it. Now, if you have a data set, let me show you how you would have done this. Let's say you were doing a problem online and it has a data set. So let me put some data. Online, you just click, on the data set and it will open in StatCrunch automatically. I'm just gonna come up with some data. Okay, so let's say you had a data set and you need to find a confidence interval. Usually when you have data sets, guys, it's T interval. It's always, most of the time it's a T interval. So we go to Stat. You go to T-stat. Unless if it is Z, you know for sure it's Z, you go there, but it's T. One sample. We're only doing one sample in this chapter with data now. Watch, with data. Where is your data? You just selected. And then what do you want to do? Confidence level is 0.95. That's it. That's all you have to do. And watch, guys. Here's the confidence interval. It's between, the mean is between 5.912 and 14.26. Okay, so I will demonstrate StatCrunch when we do the proportion as well. So I'm going to stop share this and take you back to the other screen. All right, let's do the next 3. I think there are 3 more exercises in here. A college professor has office hours from 9 a.m. to 10:30 a.m. daily. A sample of waiting times to see the professors in minutes are listed here. Assuming that sigma is 7.84. So this is unusual problem. He gives you, I told you, usually a data set, it turns out to be a T interval. But look what he says here. He says, assuming that sigma is 7.84. So he's giving you the population standard deviation. So we have no choice but to do a Z interval here. Find a 95% confidence interval for the population mean. If this was not there, guys, it would have been simply a T interval. Okay, if you have your calculator handy, let's do this together. So we need to enter the data in L1. I will do it with you guys. So you got 10, 12, 20, 15, 17, 10, 30, 28. Probably this is the largest data set that you will see in this chapter. 35, 28, 19, 27, 25, 22, 33, 37, 14, 21, 20, and 23. All right. So now I'll go to stat, calc, tests. Okay. Because, guys, he gives you sigma, this should have been a T interval, but since he injected sigma in there, it will become a Z interval. Okay, I don't have a summary. I have a data, so I just select data here. Okay, you see where the prompt is asking you to do, to find sigma, to input sigma, that's why. So we have the value of sigma here, which is 7.84. And then my data is in L1. Frequency never change, guys. And then confidence level is 95. Is that 95 that he wants? Yeah. And here's the interval, 18.86 to 25.7. I'll write it down. So Z interval input, I'll write down here. The input should be data, put in L1. And then your interval is, I would suggest, guys, when you just redo those problems on your own. I know it might make sense to you as you watch me doing the work, but the real challenge, or just to make sure that you grasp the stuff, is you just do it on your own. So this is the interval, and you can say with 95% confidence, you can say that the true mean wait time for the professor is between 18, that's a lot of wait time, minutes, and 25.74 minutes. Now, if sigma was not there, guys, if he didn't say this statement, I might give you the exact same problem on the test, but without saying this. Here is what you do. Watch. So no sigma. As I said earlier, you just go to stat, calc, tests. You do a T interval. And then data. And look, do you notice on the screen there is no mention of sigma here, because this is not needed here. Just input data, list is L1, frequency is 1, confidence level, you get the interval. You're going to get a different interval, guys. That's why I'm telling you it's important to distinguish between the two. Let me show you what the interval would be if that was. So you cannot just take your chance with this, guys. You need to understand which one you should use. Calculate 18.53 and 26.06. That's not what we got. You see, we got 18.86. I mean, it's close, but it's not exactly what we got. Next question. University administrator proposes to do an analysis for the proportion of graduates who have not found employment in their major field 1 year after graduation. In previous years, the percentage averaged 7%. So that's information about the previous years. He wants the margin of error to be within 4%. So E is 4%. Remember, the word within gives you the margin of error. At 99% confidence, C is 99%. And for C, critical value, guys, I don't know if you still remember, we did it several times, it's 2.575. And it is listed at the bottom of table 4, this critical value. What sample size will suffice? Oh, even I'm giving you here a hint. Use 2.575 as the critical value for the 99%. So you have the critical value. So N equals. This is a proportion, guys. So this is the formula. Okay. equals. Who can tell me what a p hat here? I think he gave us prior knowledge about a p hat here. If he doesn't say anything, he put 0.5, 0.5. But he did mention something. He says in previous years, the percentage average is 7%. So what do I use for p hat here? Yes, 0.07, yeah, man. Correct. And what would be Q hat? Q hat is the complement, guys, the total opposite. So it will be 0.93. And if students wondering where I came up with a 0.93, I took 100% and subtract 7% times 2.575 squared divided by 0.04 squared. Students sometimes make the mistake, they don't convert the 4% to a decimal. That's wrong. You have to. You cannot put a 4 here. It's 4%, which is 0.04. So if we do the math, guys, let's see. I'm just going to do it 0.07 times 0.93 times 2.575 squared. I'll show you the screen once I put it, divided by 0.04 squared. So this is how you enter it. All right, and let's see what the answer is. 269.78. You have to round up, so 270. It's always at least 270. Number 4, a survey of 865 voters in one state reveals that 408 favor approval. So this is section 6.3, guys. And this one was 6.3. This one was 6.1. And the previous one was 6.2. A survey of 865 voters, that's N, in one state reveals that 408 favor approval of an issue before the legislature. Construct a 95% confidence interval for the proportion. So this is one prob C interval. I'm going to do it by hand, by calculator, and by using StatCrunch as well, guys. So prob Z interval, you go to stat. No confusion here. There is no T or Z. It's always a proportion Z interval. It's a proportion interval. So just go to tests. I think it's letter A, we believe yesterday. One prob Z interval. Okay. 408. I already have the data in there. X. N is 865. The confidence level is 95. As you can see, it's a very common confidence level. And hit calculate. So P is between, you see, P, this is the confidence interval right here. And this is a P hat, which is the sample proportion, X over N. So if you divide, guys, 408 by 865, you should get 0.47167, etc. That's P hat, the sample proportion. So let me write it down. And I got 0.438. And I got 0.505. Okay, how do you write the conclusion, guys? You say with 95% confidence, you can say that the true proportion in my math lab, they might trick you and they put a statement that the sample proportion is between. No, we're not about, this is not about the sample. You do confidence interval for the population proportion, guys. We already know the information about the sample. Any statistics we do, guys, we don't do it for the sake of the sample. We do it for the sake of population. That the true proportion of voters who favor, I'm just copying and paste the language, approval of an issue before the legislator is between you do it as a percent, it will be easier to understand. 43.8% and 50.5%. If I ask you guys, do this proportion of voters make a majority or it is a minority, what would you say?
A majority.
Why do you say a majority?
Because it's over 50%.
Yeah, but it could be also on the low side, right? Because it can be as low as 43.8 and as 50.5. So for this one, you say no, it could be below 50%, it could be above 50%. But if your interval was, let's say, 50.5% to 57.5%, then you can make a conclusion that it's going to be a majority. But with this one, it could be, and it is possible that it's not, because the interval has minority and majority figures in there. All right, guys, so this is number 4. Let me show you how to do this one using StatCrunch. Okay, I'm gonna show you how to do this using StatCrunch. Okay, proportion. We're doing proportion statistics. So Z is for section 6.1, T is for section 6.2, and proportion is for section 6.3. One sample, guys, with summary. I don't have the actual data. Okay, number of successes is X. And what did we say X was? 408. Number of observations, which is N, 865. We're not doing hypothesis testing, so you select confidence interval. And I want the 95%, okay? Compute. Here you go, guys. Lower limit, 0.438, upper limit, 0.5049, which is 505. That's what I put. See how neat you can do that? Not only you can do that because there is a project that's going to come toward the last 2 weeks of classes, and you need to use StatCrunch in order to copy and paste your output into Word document you just selected, and copy, and or do a Control-C. He's asking us to do a Control-C here, and then go to a Word document and put a Control-V for the information. So this is how we use StatCrunch here. Let me go back. We're back to our lady bug software. Okay, now I have a review for chapter 6. I have some questions for you. You will get this handout from me this afternoon after we're done today. I'll scan them all. Okay. We're going to be using technology throughout of this handout, guys. So what I'm going to ask you to tell me, what do we use? Is it a Z or T for the mean or proportion? What kind of calculator feature function do we use? And then I will do the work, but I need your participation, please. Okay, let's read the first question. Many people think that national lobby's successful fight against gun control legislation is reflecting the will of a minority of Americans. It's only a minority that they want, just bills on gun control. A random sample of 4,000 citizens yielded 2,250 who are in favor of gun control. Estimate the true proportion of all Americans who are in favor of gun control using 99%. When he says estimate, guys, it means he wants a confidence interval. As I told you before, this chapter in some books, it's called estimating the mean and the proportion. We know we cannot estimate it with one value. We can estimate with an interval. So that's why we need to create an interval here. Okay, guys. So what feature do I use? I'm going to list the 3 of them, and you tell me which one. Once you know which one you're using, you are in good shape. So which one is going to be, guys? First, second, or third? And I hope not Z interval. It's not the mean here. The Z interval is to find the mean. He's talking about the proportion, guys. Estimate the true proportion. So it's number 3, yes. You have X, which is 2,250. You have N, which is 4,000. And you have the confidence level, guys, which is 99%. And that's all you need. And watch how simple it is once you figure it out. Okay, let me do this with you guys. Turn the calculator on. Okay, to clear the screen, you just hit clear here and then go to stat. Prop Z interval. Okay, so what do we have here? 2,250. The smaller value is X first. Then N is out of 4,000. And the confidence level, guys, is 99%. And you're done. Here you go. So 0.54.
Sources?
Yes.
Because I can only find chapter 5.
0.5423 and 0.5827. That is the interval. And just be careful about how many decimal places you have to round. The system will tell you if you're doing it online and how many decimal places you should be rounding. Okay, any question? Now a question to you. Is it based on the interval? Is it a majority or a minority who favor gun control? You see, that's how polls are done. This is how CNN makes predictions. It's based on all those confidence interval and hypothesis tests that they make. So what do you guys think? Is it true that it is a minority of Americans who favor gun control? It is a majority, guys. And you know why? Look, the percent goes from 54% to 58, so it's about 50%. Whereas in the previous interval, no, we could have values less than 50%, we couldn't tell. This one, guys, you can say, I'm 99% confident that the majority of Americans favor gun control because it's over 50%. Just so you feel, guys, the power of what you're learning today, it's very important. Number 2. A researcher at a major clinic wishes to estimate the proportion of the adult population of the United States that has sleep deprivation. How large a sample is needed in order to be 99% confident that the sample proportion will not differ from the true proportion by the more than 5%? We did this exercise yesterday. This is E, and this is C, and it's a sample size about the proportion. So this is the formula, guys. So let me just do this. 99%, guys, please memorize this value. It's 2.575 squared. E is given to us as 0.05 squared. And he didn't give me P hat and Q hat. If he doesn't give you the sample proportion, you guys, you use 0.5 and 0.5 for Q. And let's see what the answer is. All right, I'm gonna do the math quickly. And then later, guys, please sit down and try to do it. Please keep in mind, this is a 7-week course, so you're expected to do lots of work. 663.06. And if this was a free response, guys, you should not put 663.06. That will be wrong because the sample size can't be a decimal. and you have to round it up. So this is your answer, 664. Next question. A researcher wishes to estimate the number of households with 2 computers. How large a sample is needed in order to be 99% confident that the sample proportion will not differ from the true proportion by no more than 6%. So this is E. And the confidence level, again, is 2.575, guys. It's going to be the same number. But he says a previous study indicates that the proportion of households with 2 computers is 21%. So this is a P hat. We have prior knowledge of it. So it's not a 50-50 now. So you do this. N equals P hat, Q hat, ZC squared divided by E squared, which is 0.21 for P hat. And Q hat is the complement, guys. So it's 1 minus 0.21. Times 2.575 squared divided by 0.06 squared. And don't forget, I'm not going to do this answer. Don't forget to round up always. Number 4, construct a 95% confidence interval for the population mean. Assume that the population has a normal distribution. A random sample, so C is 95. N is 16. A random sample of 16 lithium batteries has a mean life, X bar, of 645 and a standard deviation of 31. He's not saying population standard deviation, so this is the sample. So can you guys tell me what interval do I use? Z interval, T interval, or proportion Z interval? One response, please. T, yes. Diva says T, it is T indeed, look. S, guys, that's T interval. And let's do it. So I hope that's making more sense to you with now. It does take a lot of practice just to be able to distinguish between the two, guys. So tests, number 8, enter. I don't have data here. I have a summary, so it's a stats. X bar is 645. S is 31. Again, guys, you only put sigma if he says population standard deviation. If he doesn't, guys, take it for granted. It's S and it's a T interval. N is 16. And remember also I said when the sample size is usually T. Is small, it is usually T. Okay. The interval is T is mean is between 628.48 and the other one 661.52. Okay, let's go to the next part. A random sample of 10 parking meters in a resort community showed the following incomes for a day. Assume the incomes are normally distributed. Find a 95% confidence interval for the true mean. Didn't mention population standard deviation. He gave you a data set. As I told you, most of the time, except for the question I did earlier, it will turn out to be a T interval, guys. So put this data in L1 and run a T interval. And let's do it together. So what do I have here? I go to stat, edit. Okay, I'm gonna keep the data in L1. I'm just gonna put my data in L2. So what do we have here? 3.6, I'll enter it. 4.5, 2.8. You can do it at the same time with me. 2.6, 5.2, 6.75, 4.25, $8, and finally $3. So I got the data, guys. And let me show you how to do the interval. You go to stat, tests, and T interval, data. Okay, I need to change this one. How do I change the list? You press the second key and then number 2. Frequency, never change it. And what does he want? A 90% confidence interval? Yeah, 95%. And then hit calculate, guys. There you go. So the mean is, I'll write it down. So input is data. Make sure you use data here. Mean is between 3.39 cents. You need, this is in dollars, so you have to put 2 decimal digits, and 6.01. If you're asked to interpret, you say with 95% confidence, we can say the mean amount, the mean income on a parking meter in general is between $3.39 and $6.01. Number 6, a doctor at a local hospital is interested in estimating the birth weight of infants. How large a sample must be selected if she desires to be 99% confident, that's C, that her estimate is within 4 ounces of the true mean, so that's E. And he's talking about the mean, guys, so you have to use the formula for the mean, which is this. When it is a proportion, we use the one that has a p hat, q hat in it. But when it is a mean, we use this formula. Okay, what is ZC? 99%. As you should know by now, I used it already 4 times today, so it's 2.575. Assume that sigma here, change it to sigma, equals 5. So he gives me sigma, which is 5. And divided by the margin of error, guys, which is 4 ounces. And don't forget to square. Okay, let's do the math here. So I got 2.575 times 5, divide by 4, and then I'm gonna square everything. And I'll tell you what the calculator gave me. I got 10.36, and you know you have to round up. So that's gonna be 11. Next question. A survey of 1,010 college seniors working towards an undergraduate degree was conducted. Each student was asked, are you planning or not planning to pursue a graduate degree? Of the 1,010 surveyed, 658 stated that they were planning to pursue a graduate degree. Construct a 98% confidence interval. Okay. So N, guys, is 1,010. X is, 658. And the confidence level is 98%. And can a student tell me what's the name of the interval that we're gonna pursue now? I'm sure you should know by now. Prop, yes. The proportion Z interval. Guys, this is the only one for proportion. And it does say for the proportion. Look, guys, this is the word right here. So this is it. Prop. And let's do it. I'll do it under the stat tests. Okay. Prop Z interval. There you go. X is 658. N is 1010. And confidence level is 98. There you go. I'll write it down. 0.6166 and 0.6864. That is the interval. Okay. Number 8. So that's section 6.3, guys. That is section 6.1. 15 randomly selected men were asked to run on a treadmill for 6 minutes. After the 6 minutes, their pulses were measured and the following data were obtained. And let's see what the question was. It's going to be find a 90 confidence interval for this. So let me just get that. But before we do that, guys, why don't you put the data into a list and then we can answer the question. So let's let me put the data into L1. I'm going to do L3 for this. All right. Okay, I'll leave the calculator away. So we got L3, 105, 94, 98. Practice makes perfect, guys. So if you have your calculator handy, do it because it will be easier for you when it comes to doing the actual test. You already did some practice. So 85, 84, 124, 122, 114, 97, 101, and 90. Okay. Just 1 second here. Okay, here's the question, guys. Construct a 90% confidence interval for the mean. So what is it going to be, guys? Z, T, or proportion Z interval? One response, and then I'll move on. I get a Z. Do you guys agree? I have a response of a Z.
Yeah.
Yes, sir. Why Z, guys? We don't have the population standard deviation. So that means you guys, you're still confused about this. I have the data. It's not Z, it's a T interval. You only use the interval when the population standard deviation is given to you. He only gives you a data set here. It must be a T interval. T distribution. When I say T, I'm referring the T distribution. The T distribution is used when the population standard deviation is not given. Where in this problem he mentions the population standard deviation? Nowhere. Only one question today we did, you know, he says sigma equals, then you use Z. So this is a T distribution. It's a T interval. And here's how we run it. You go to stat, tests, and then T interval. My input is data. I put it in L3, guys. So I press second and number 3. And I want a 90% confidence interval. Okay. So it's 94.87. 94.87. And the other value is 105.93. I want to show you guys, even if you thought it's Z interval, it wasn't going to work for you. And let me tell you why. If you go to stat, tests, Z interval, let's say you were going to do a Z interval, you're going to get stuck here. Watch. Data. You see what it's asking you here? It's asking you for sigma. You don't have it. What are you going to put in there? You have to put something. You can't just make up a number and put it there. So it wasn't going to work anywhere. So when you have a data set, unless if he gives me sigma, take a note, guys. 99% of the time, it's a T interval when you have a data set. I hope that this will make it a little bit more clear. What I'm going to do now, I'm going to go over, well, since I decided to extend the due date for chapter 4 and 5, let you submit them today. I was planning on going over those 2 assignments, but I'm not gonna do that now. I will provide the answers tomorrow for everybody. What I can do now, I think that's the review for chapter 6. And let me show you where the practice test is and just go over it a little bit. So I'm not gonna start chapter 7 today. So that's probably good news for you.